Let's go and take a look at the details of describing a sampling distribution of proportions. Because now remember, we're talking about a proportion and what do we expect, right? So we know the shape is normal from the distribution. Again, we're doing a sample over and over again, and we're analyzing a proportion this time. And we're hoping that that sample proportion, right, estimates the population. And so when we look at the distribution of those multiple samples, right, of different sizes, approximately normal, right, if we know n times q, n times p is greater than 10 in this case. We know the center of that sampling distribution, the mean of the proportions of all the sample proportions, right, because we're doing it over and over again, is equal to the population proportion, right, because of the unbiased nature of a sample proportion mean. Back to that conversation of accuracy, precise that we had earlier. And then the spread of a sampling distribution, right? Because we're looking at the proportions, right? Sample proportions, the means, would look like this here. And it's the standard deviation of the proportions, or the standard error again. Thinking about that language right there, the standard error is an important term to recall, right? Where is that? Um, right there, the standard error. Sorry, it's green. Standard error. And that's the formula for proportions, not for means. Remember, means had a different one. Standard deviation divided by square root of n. This one is p times q divided by n, square root of that. So looking at this sample here, how will we describe the sampling distribution of p hat if we know p is 0.75 and you have a sample size of 115? What would the sampling distribution look like? Well, we check to see that is normal. It is doing that calculation. We know the center of the distribution is going to be whatever p is, 0.75, and the spread is 0.041. So what that looks like would look something like this, right? We have a distribution, and now we're talking about proportions. We're doing proportions, and now we're looking at the distribution of proportions, where in this case the sample is 0.75, the center, and then it's the standard error in this case, which we just calculate. Oh, sorry, you can see it over here. The standard error is 0.04. So then you would see this would be 0.79 because you would add, right, the distribution, 79%, add another 0.4, that would be a 0.83. So we can start to see what we would expect to see if we did a sample of 115, as we said, and look at the proportion would fall within this type of distribution. A normal distribution, we'd go down one. This is 0.71. So that's what we're trying to analyze here. So we'd still use the normal distribution, but instead of for the mean, I know it's a little counterintuitive. For the mean, we're putting 0.75, sorry, 0.73. And then what we ended up with when we did that standard error, because we're looking at a distribution, right? We're looking at a distribution. The standard error was 0.014, so 1.4%. So then there's the distribution. And what we were looking for was what's the probability that they're more than 3% away from the true proportion. And so we did, what's the probability that it's less than 0.70? And we got an answer, right? And then what's the probability that it's more than 0.76, because that's more than 3% away from the 73. You got those two numbers there, and that's what gave us those values we had in our notes there. So that's how we use the ArtistStat to do those calculations. And so then on the last example, we'd follow the same format. What's the mean? What's the standard error, right? The standard deviation of all the sampling distributions of 30 people. You would end up with those, and then you'd be answering this question. This was a little bit more, this is a percentile question, but using the mean and standard deviation, or the standard error. If we sample through 30 students, there's a 90% chance we find between what percent, right? What percent of students, what percent, 90% chance we find between what and what of the sample will have debt, right? And that goes back to 62%, right? That's our average, have some debt. And so what's the chances? We sample 30, there's a 90% chance that from what to what. and we see from 47% to 76% have debt there. And again, let me see if I can zoom in a little bit here. So we could take a look. What you would be using is you would be finding percentiles on normal standard on the normal calculator. You're doing a 90%. Use the mean and standard deviation that we have up here, and then it gives you those numbers there, 47 to 76. So it's a percentile question here, right? Because they're asking you to find the values and when they give you the percent.